Welcome to the 2.11 SBW help video, Reasoning about Area and Volume. By the end of this video, you should be able to use dilation to compare the area of scaled images, solve area problems using dilation, and write a paragraph explaining your knowledge. In this video, we will review perimeter and scale factor, review area formula, review area ratio, complete an example SBW, and review your SBW 2.11. Here is your perimeter review. Perimeter is the distance around a plane figure. The perimeter of a polygon is the sum of the lengths of its sides. The example shows how to find the perimeter of this triangle. Perimeter is equal to A plus B plus C. A is equal to 9. B is equal to 11. C is equal to 14. 9 plus 11 plus 14 is equal to 34, which is the perimeter of this triangle. Scale factor review. A scale factor is the number by which all components of an object are multiplied in order to create a proportional enlargement or reduction. The ratio of triangle A to B is 2 to 1. The ratio of the perimeter of triangle A to B is 28 to 14. Notice 28 to 14 can be simplified to a ratio of 2 to 1. Also, notice that the pre-image, the one that we begin with, our smaller triangle, goes on the bottom. The larger triangle, our new image, goes on the top. If we were to do the scale factor of 1/2, we would have a different ratio and a different scale factor, 1/2 versus 2/1. This is an area review. Notice this is a rectangle. Remember, the area of a rectangle is base times height. What would happen if I slice my rectangle in half? Now I have a triangle. Area of a triangle is half of the base times the height. Ratios of area review. If two similar polygons have the lengths of their corresponding sides in the ratio of t, then the ratio of their areas is t squared. We always have 3 steps to follow when finding the ratio of the area scale factor squared. First, we'll square the scale factor, then we'll set up a proportion, then cross multiply to solve. In this example, a triangle with an area of 25 inches squared is our pre-image and is dilated by a scale factor of 3. What is the area of the new image? First, we take our scale factor, 3/1, and square it, which gives us 9/1. Then we take that squared scale factor and we set it up in a proportion with our pre-image on the bottom. Our unknown image, x, is on the top. Now we're going to cross multiply. X times 1 is x, and 9 times 25 is 225. This tells us that the area of the image is 225 inches squared. Here's your example writing prompt. Notice the numbers have been changed to protect the problem. The two figures are similar. From our study of similar figures, we learned that corresponding angles are congruent and corresponding sides are proportional in similar figures. There is also a relationship between the perimeter and areas of similar figures. Find the scale factor and perimeter of the triangles. What is the relationship or ratio? The ratio of the areas is the square of the scale factor. What is the area of the small triangles? In this example, we will use these sentence starters and fill in the blanks. This will be triangle A, and this will be triangle B for our example. The perimeter of triangle A is blank, and the perimeter of triangle B is blank. Notice for the perimeter of triangle A, we have 9 as one of the sides, 18 as another side, and 13 as the other side. These measurements added together add to 40. For triangle B, we have 18 plus 36 plus 26. When we add 18 plus 36 plus 26, we have a perimeter of 80. Now that we know the perimeters of both triangle A and B, the scale factor of triangle A to B can be found. Notice if I take our new image, which is 18, or the length of one of the sides, and then the length of the side of our pre-image, and set them up as a fraction, 18 over 9, or 9 to 18. I would also have a ratio, which is 2 to 1, or a scale factor of 2. The ratio of the perimeter of A to B is 80 to 40. This can be simplified to 2 to 1. This means that the relationship of the scale factor and the relationship of the ratio of the perimeter is the same. Since I found the scale factor and I was told the area is the square of the scale factor, the ratios of the area can be found like this. First, I'm going to check the scale factor. Remember, it was 2. And then I'm going to take the area scale factor and I'm going to square it. So 2 squared is 4. That means the ratio of the areas is 4 to 1. The area of the smaller triangle is base of 18 times height of 7 divided by 2, which could also be known as half the base times the height. Notice that the area of the smaller triangle is 63. Now, this is a great example of why we square for the area. In the larger triangle, I'm going to go ahead and write out how I would multiply each of the base and the height times 2. Notice here my base is doubled. It's 36 inches. And since I need 18, I'm sorry, the base, yeah, is 36 inches. So since I need the base to be doubled, I'm going to say 18 times 2. Then the height was 7. Notice here, it's doubled. That's 7 times 2. If you look, you have 2 times 2, which is the same as 2 squared. 18 times 7 is 63. 63 times 2 squared is the same as the scale factor squared. 63 times 2 squared gives me 252 inches squared. Now, I did go ahead and divide all of this by 2 when I came up with 252 inches squared. Your writing assignment for today says the two figures are similar. From our study of similar figures, we learned that corresponding angles are congruent and corresponding sides are proportional in similar figures. There is also a relationship between the perimeter and the areas of the figures. Find the scale factor and perimeters of the triangles. What is the relationship or ratio? The ratio of the areas is the square of the scale factor. What is the area of the small triangle? Notice the numbers have changed and they are different in this example, in this writing assignment, than they were in my example. Go ahead and fill in the blanks of these sentence starters. Contact your teacher if you have any questions.